Thank you for coming. This talk is not about adding a new language, not like creating the new language from scratch, because, well, I want to get finished with it at some point. So rather, this is giving you access to all of Scheme via indentation-sensitive formatting. Also, it won't be as flowery as the talk by Ricardo, which I like very much, because it's a report. It's a report of the steps toward the 1.0. So actually toward getting this done and completed, that I can say, I don't think that there will be any changes after today. So the talk is about my experience with Wisp. 5 years. It's now 5 years since I started this. And the idea was that I looked at Scheme and really liked it, but I got a problem with the parents. And I think that's a problem many people have. Yeah, so let me get started. This here is an example of how Wisp looks. The canonical example I use everywhere because I like it a lot. And I started in 2003. Since 2015, this is specified in the Scheme request for implementation 119. And it's now at version 0.9.9.1 because I missed adding some Emacs files. So short about me, I won't talk about everything which is there. I started programming only in 2006 with Python and used that for 6 years in the PhD almost exclusively. But in 2013, I started going into Scheme because I realized that I'm hitting limits of Python. And I saw that in Scheme I can actually go further into how programming can be, and not just into using things other people do or just having to go deep into the compiler. The parents shouldn't worry me because I've been using Emacs since about 2008. I've been looking into eLisp, so it shouldn't hurt me, but it still does. I'm strange. Since 2017 now, I'm actually working full-time on Java, so I saw the other side and I'm seeing the other side daily. So I can really appreciate what I can do here. Also, we had this about education here. Last year, I had the chance to give a networking technology and communication class at university. And there I could actually use the language to describe to them how an algorithm works. And they asked me whether it's pseudocode. So I was really happy about that. Yes, the part below you see. I have, my wife and kids are sadly not here, but if they were, I wouldn't have time. So maybe that's good right now. So what is Wisp? The vision of Wisp is really to get a syntax like Python, but with keeping the simplicity and power I see in Lisp. The way toward that is to get the outer parentheses away by just inferring them from indentation, to have inline parentheses for some added beautification, to do infix math just by shelling out to some work other people did before me, and to survive HTML, which Python sadly does not manage. So I knew that it is important. So, but let's go back. Why is actually Scheme great? When you look at the readability of Scheme, while the parents make many people think that it's hard to read, when you look at it in detail, you see that all the control structures are just the most common letters you can use if you omit normal A to Z and you omit the math characters and the numbers. All the rest, this is, when you look at the order, just the order in how common they are in normal prose. I actually looked at newspapers and books and so on. So this period, comma, quotes, colon, and so on, this is the order how common the characters are. And these are just the characters used in Scheme and Lisp. So when you're looking at that, it is really close to just looking like prose. And also, it is flexible enough that you can program your compiler at runtime. So you can actually build everything without relying on the compiler developer. But I would like to ask you to look at these two code snippets, the one above and the one below, and then think about what if you showed it to your son or your daughter? What would they perceive as easier to read? And for me, that answer is clear. And this is why I'm doing this, because I think that it's actually easier to read. So, in short, there's a kind of elegance for me. Scheme provides homoiconicity, I can never speak that right, which just means that you cannot distinguish between code and data if you just look at the subpart of the code of your program. It can both be the same, can both look the same. And you can use code as data and data as code. And then it uses the most common characters. But the elegance I want to add is that the first and last characters of a line shouldn't just be a parenthesis, because then you lose the strongest identifier of each line to always the same character until you manage to unsee it. So why Wisp? I want the simplicity and elegance of scheme with the readability of Python. And I now show you visually how this is done. I had a longer talk about the details here, so I just show it. This is scheme. And this is already valid Wisp. I go back, you see the parentheses, they disappear, and the one thing which appears are these periods in the beginning. Because Wisp just inverts what scheme does and what Lisp does. It does not mark where you call a function, it marks where you don't. And since where you don't call a function, in the next part, when you want to call a function in the next part, you actually don't need to add more indentation than before. You do not need to finish the period. So you actually minimize the syntax from you need 2 characters at the beginning and at the end to just 1 at the beginning, and lines which do not start a function call are much less common in scheme. I actually grabbed the Geil source code, and 2/3 of the lines start with a parenthesis, and these 2/3 of the lines now do not need that anymore. So the syntax overhead is cut by about factor 4. Okay, next step. You see the parentheses here. They are okay, but sometimes you want to avoid them because inside parentheses, Wisp parsing is disabled. So you can always paste in scheme verbatim and it will run, because this will just be run through the scheme reader. So you can remove them, which then makes this look even simpler if you're not used to parentheses, but that's not the reason why it exists. The reason why it exists is that for constructs like let values, you need 3 parentheses after each other. So you need a way to represent this is an empty parenthesis, and after it there comes another one. And this is what the colon on the empty line does. It just says, here is an indentation level, add a parenthesis and check the next line. And the inline parent just comes from that, because when you have syntax and you already take up that space, then you should use it as wide as possible. Next part, I had a colleague who looked at my scheme code and said, prefix math. And I realized, yes, this is a problem for many people, and for some, especially smaller mathematical expressions, prefix math is hard to read. So I just activate srfe 105, that's curly infix. So in Wisp you can always use this expression. Just curly braces around that and you have infix math. You can also do it in scheme, by the way, at least in Geil. Just add this curly infix marker and then you can use infix math. And finally, there's HTML. It won't go away. So we need something which can survive when you strip away, when you collapse all spaces into one. And this is here the leading underscore. You can, in Wisp, always replace leading white space by underscores. You just need to keep one single leading white space at least in front of your token, because otherwise it cannot distinguish between that. So when you write code like this and you post it into a forum, someone can always copy it, throw it into the REPL, and it will run. So that's it. That's the basics of, no, actually that's all of Wisp. The indentation is used to show the outer parentheses. Leading period is used to say, this does not start a procedure call. The colon provides double parentheses and inline parentheses. And inline math, infix math and underscores are provided for convenience, because otherwise it's really hard. There are some things which just, the infix math, that's something where people just say no and suddenly they are out. And this way we can avoid that. So now we come to what I actually want to say here. That's the past 5 years, because I used Wisp for about 2/3 to 3/4 of my hobby projects in the past 5 years just to see whether it works. And I found 2 things which should be changed and which I already changed. That's a literal array. Currently you can make a literal list by just saying quote and the line afterwards, and it is interpreted as the line is quoted. What was missing is I couldn't do arrays, and Guile only treats an array as property of a function if you actually take a literal array. If you say this is an array, then it doesn't do it. So that was sadly needed to add this. And then there's a trailing period to make the REPL more convenient. But with these changes, I don't see anything else coming. And this is the changes since 2015. So there wasn't a lot. So I think it's stable. Here's a short overview of the stuff I did. That goes from writing Py to Guile, that was reproducing all my workflows from Python in Guile. Then implementing advection diffusion, building function parameter estimation. Actually, the first part was work. Then there comes game scripting. That was what can I do with Wisp? This is what Christopher presented last time here, which was really great. I saw it in the stream. And then I built a password generator, which I'm using now. Built a network simulator. All this stuff afterwards is networking. Hemming code. The Hemming code is actually an implementation of a Hemming code for a lecture. And then there's Dry Its Wake. This is game scripting again, because a colleague left to a game company and they wanted to give him a present of something he can show all the game scripters, hey, this is how it could look. So the first change is what you see here, the 2 hashes. That makes a literal array, and with that you can implement doc strings in Guile, which are almost like tests in Guile, doc tests, which are almost like the doc tests in Python, with the difference that in Python you write them in the string, and if you make line breaks, everything breaks until you figure out that you have to quote them. Now in Wisp, and this actually also works in Guile now in normal scheme, you can just define these doc strings and they are normal code. So you write them like you would write the code for that. No difference between your code, your doc test and so on, it just works. But for that I needed this extra syntax here. And then in the REPL, typically in Wisp, if you run an expression, you have to type enter 3 times to have it executed, because it waits for 2 empty lines to say this block is finished. This is the same in the REPL and in the file, but end of file also counts. Now in the REPL, you often just want to say, I want to execute this expression. So if you put this period behind that and press enter, then it's executed right away and treat it as the block is ended here. You can also use this in code files. Question? Yeah?
Actually about the previous slide, but adding the literal array aspect, my impression would be this would be the first addition to Wisp that's doesn't apply to every S expression language, right? Because our
Yes.
other one would always just any S expression
Yes.
language, it would always transform. Is that correct?
Yes. And in this case, this just takes it and I think it transforms it with a macro. So I'm not perfectly sure. Oh, repeating the question. Yes, you asked whether this is the first change which doesn't apply to every S expression language. And yes, it does not apply to every S expression language. So this is something which is unfortunate to me, but which I needed to get this working in Guile. For doing this in another scheme, for another language, another S expression language, I would leave that out. Okay. And this is the game scripting. So what you see here is I'm using actually a procedure for a scene, and then this is stolen from Shakespeare. The people who are in there enter. You say enter and then the name. This defines a macro for the name. And then you can just use the name here and type below that what it does. And all of this is implemented in macros. So there's no special syntax in Wisp for that. It's just that you can make a macro which looks at the content of the next line, interprets it as symbols, looks at the names of the symbols, takes a string out of that, and then shows it character by character, which is really cool that this is possible in Scheme, and which is one of the justifications why I think that this is something where we should go. And now I think there's time for a short break here, because I've been talking the whole time, and I should actually stop talking for 30 seconds. This is how the game looks. I don't get it much bigger, sadly. Basically, here it asks you a question, you answer that, and this question is what you had in the slide as choose.
So is that textual RPG again?
Yes, it's where I want to go, and this is what I want to use for games. Because there you have the writer in the front seat. The writer can always change things and just calls scenes and calls actions, which is an inversion from the writer having to wait for a feature coming available by the one who writes the scripting language. And you have all of Scheme available here. Here. This here, these are just normal procedure calls. As you can see, if you know Scheme, actually there's quasi-quoting around the lines. So this is an executed statement. And the result is actually printed. So this is what I did here. Now we come to the educational part. Last year, as I said, I had the chance to use Wisp in a lecture. And they implemented Hamming code for them to show it to them so they could actually understand it from a working example. And this is how that looked. This is the Hamming decoder. This is an 11.7 Hamming decoder, so it takes 11 input bits and extracts the 7 content bits from that, and all the while corrects up to 1 bit error. It takes here the bits. The C bits are check bits, the D bits are data bits, and then it just calculates the modulo 2 sum of the first check bit and the associated data bits, multiplies it with 1, and then it does the same for the second check bit up to the fourth. And by adding all these, we find where the bit is flipped. Then it flips the broken bit and just extracts from the fixed bits again only the data bits, so the bits starting with D. Question?
Why use the leading underscore in this slide?
Because a language does not only have to survive HTML, it also has to survive minted, which kills your indentation when you have more than 8 characters of white space. So this is unexpected advantage that I could actually do that, because otherwise this would be garbled. So not only HTML is white space hostile. I'll skip this and just go, since I only have 5 minutes left, I think, and just go into where it helps me in learning. So first part, who among you writes code by hands? Who has, let's ask it differently, who has written code with pen on paper?
Okay, we'll force it.
Yes. I mean, for university, I had to make.
You had to for, okay.
Yes, I mean, my exams were in paper.
Actually, horrible. Okay, yes.
Unfortunately, just 2 times, and we did the kill the creature.
I actually do this to understand complex stuff. For example, the network simulator, I wrote like that in my notebook here. And that's how I really understood what I'm doing. And I think that helps a lot. And you see in the writing, this is pretty natural to write down code like that. Then Scheme has a beautiful elegance that lettering.
It means you can talk for a few more minutes, but we need to switch speakers.
Okay,
Yeah,
so let me check. Okay, I'm leaving out these parts. Some of these are already said, and jump forward to one of the things I found which works. Use more inner defines in Wisp than in Scheme, because the indentation is because deeper indentation is more nasty than deeper nesting in parentheses. So this is one thing I found which I do differently. And then always prefer procedures over macros when you can, and prefer macros over reader extensions. This is why Wisp doesn't do a lot in reader extensions, because these are nasty to debug and interact badly with other stuff. So skipping this. And so there's finally the future AZ. I want to explore more possibilities here without changing the language itself. It needs more documentation and better tooling. For example, publishing is really unsolved. This is horrible. And then I would really like to get it into Guile at some point. And for you, the next time you get to write pseudocode, it would be really cool if you would try to write it as Wisp you can execute and talk about it and tell me, because that's one of the best things to see when someone uses this. And with that, thank you.